Very often in science, we want to show the correlation between two different datasets with respect to the same variable. In order to emphasize this correlation and save some space, people often use a single chart with dual y-axis. However, together with many other chart experts, strongly believe that dual y-axis charts should be avoided as they can easily mislead readers. We'll start with an example. Imagine that we want to show electricity production in Germany over time, and we also want to showcase the renewable energy share over the same period. A typical graph showing this would be one such as this one. Now let's look at what are the problems with this type of graphs and what would be an alternative to this example. So what's the problem here? That our brain is used to graphs with only one scale. Therefore, when we see a graph like this, we tend to relate one line to each other and draw conclusions. But in graphs with two y-axes, there are actually two scales that are generally randomly chosen. This means that there is no physical connection between one point in one of the y-axes and the corresponding in the other one. For example, 590 terawatt hours have nothing to do with 5% renewable energy share. In order to fully understand this graph, we need to actively remind ourselves that there are two different scales here, and that the relationships that we see at first sight may not actually have an actual meaning. Let's take it while and with the same dataset deliberately manipulate the scales in order to show different messages. For example, we could assume, seeing this, that the orange line remained constant while the black increased over time, or that the black remained constant while the orange increased over time, or that they both started at the same point while the orange grew faster, or the other way around. With the exact same dataset, the first message that we get from each one of these graphs is actually radically different. There are several alternatives to dual y-axis charts, but in this video we will focus in the one that we believe is the most versatile one. That is to actually split the graph into two that share the same x-axis. In this case, we can clearly see that both datasets relate to the same period of time, but our brain can directly see that the scales of the two datasets are different. Of course, you could still deliberately manipulate each one of the scales, but it will be directly obvious to us that there is no direct relationship between the two different variables. Now we know that dual y-axis charts are very common in certain research areas, so we challenge you to send us your examples, and we will be addressing them in our blog.